Hello everyone. So today we are going to implement a strategy game camera controller. So here, as you can see, we can move around the world. This is the gameplay mode, not the editor mode. We can move around the world and zoom in, zoom out the camera and rotate the camera. So yeah, this is basically what we are going to work on today. A controller for strategy game. This is what you are going to get at the end of session. Okay, so for this I'm gonna select the top-down template because this template already has a top-down camera that we can easily convert it into a strategy type controller, and we can reuse some of the code that we already have and start our strategy player controller using the controller we got here. Okay, so I'll name my project strategy controller. Right, and this is going to be a blueprint project. Create. Right, so this is what we got, and if I play the game, this is what we have. We have a character that follows the mouse location, and we can also move around by click and dragging the mouse like this. So this is gonna be our starting point, but here the game is bound to this character. So first thing I want to do is I want to break it. That means, for example, here we might have characters in the world, but when we play, we should not have a character. We should be able to freely move around the world and click on one of the characters and control it, but we are not bound to that character. That's the way I want it to be, like in a strategy game. Okay, so for that I am going to create a dummy character. So top down blueprint, let me create a blueprint class and select pawn pp player pawn. Okay, now if I go here, first I'll add a camera just like in this top-down character. So the camera is like this. Let me just select those two and copy and paste. Okay, now if I move this character over here and possess it, see, now nothing happens, but we are not bound to this character, but it also can't move as well. And movement not allowed. We got this warning because we don't have any movement component, so we can't move this player pawn. So let me add a floating pawn movement. Now let's see. Yeah, now we can move around the world freely. Great. Okay, Now that we have the movement, the next thing I want is ability to, let's first implement zoom in, zoom out, then let's implement rotating the camera. Right, so to implement zoom in, zoom out, we need an input action. Under the action we have set destination, click set destination touch. So these are top down controller inputs, so I'll add another input action IA zoom. Now this is going to be an axis because what's this error? So oh sorry, we don't need a trigger yet, because we are going to use mouse wheel to zoom in and zoom out, so that's going to be an axis. Now let's bind this to IMC default, because this input mapping context is what already used in this top-down controller. See, add mapping context IMC default. So we need to add our newly added controller input, which is ISO, into this input mapping context. So here I'm going to use mouse wheel axis. Okay, now in the top-down controller we can actually access, oh we are still in the play mode, sorry, ISO. Right, now we can get the action value here. Oh wait, we can actually implement this inside our phone, because this is where our camera is. So I can access the sprint arm and set, we can get length, target arm length of sprint arm, and we can add to this existing one based on this value. So if this is a minus value, this will be added. If this is a minus value, target arm length will be reduced, which is zoom in. If this is a plus value, target arm length will be increased, that means zoom out. In case you don't know what target arm length is, it's this, the length of this red line, spring arm length. Okay, let's get the action value. Let's add a multiplier here, because I don't know how fast or slow our zooming would be, so to control that I'll add a multiplier here. Okay, maybe let's keep it 1. Later on we can change it. Set target arm length, and we need to clamp this, clamp float, minimum let's say 500, maximum I don't know, 2000. Alright, let's see what happens. Okay, I'm rotating the mouse wheel. It does zoom in and out, but it's very slow. So I guess we have to increase this here. Yeah, now we can zoom in and zoom out, but still we don't see the full map. So I think we can have, let's try 10,000. Yeah, this is not smooth, and we don't even move because we can already see everywhere. Wait, why are we not moving? Sorry, to move I have to press left mouse button. Okay, I can move around and I can zoom in, zoom out, but it's not smooth. So how to make it smooth, the zoom in zoom out part, instead of just abruptly stopping zoom in, we should like smoothly stop zoom in. So wait, before that let's keep it this way. Let's smooth it out in the next step. Now I'll implement rotating the camera. So for that, again we need another action, input action, IA rotate camera. This is also going to be an axis value because we need to rotate to left or rotate to right. Let's add this one also to our IMC, input mapping context, and to rotate left I'll use Z, and to rotate right I'll use X. For now actually I'm planning to use a combination of middle mouse button and mouse movement, but for now I'm just gonna use only one of the keys. So X should be whatever the opposite of Z is doing, so we can add the auto trigger negate modifier. Right now I rotate camera. So if you go here, in order to rotate, what you have to do is change in this Z value. So get this spring arm, add relative rotation, split this, add Z from, let's see, directly connecting. Now if I press X, you see it's rotating. Let me zoom out. Okay, basically it works. So if you want to move up, what you have to do is click upward and click in the whatever the direction you want to move and hold like this. Alright, now that we have basic inputs, let's see how to make them smooth. So to make them smooth, here this is not guaranteed to fire every frame, only when action triggered and the current input mode includes game. Okay, so if I do this with the lepin in the tick, this should be much smoother. So let's convert this into a no need to convert to a function. Let me delete this and connect to tick, and instead of this one I can use IA so, but still this will not be smooth. See, it suddenly stops. So we can have a variable, let's call it zoom rate, and then let's get the zoom rate lerp to whatever the value we get in here. Let's say 0.1, maybe we should multiply with the delta seconds. So get 12 delta seconds, multiply, let's say 10, I don't know, we can adjust these values. So the reason to multiply with the word delta second is to keep this change in rate constant for regardless of the machine speed. Okay, now I'm gonna set zoom rate with this lerped value. I'll clean up the blueprint soon, but bear with me. And then instead of using this value, I'm gonna use the zoom rate. Actually, we don't need it. We can use the input from here. Now we should be seeing smooth zoom in and zoom out. See, it's not abrupt as before. If you want to make it further smooth, you can wait. Another thing is, I remember there was something here smooth, but I'm not sure that do the job well. We had that for both actually. If we are trying out that, but no, still we don't have any control here, like how smooth it needs to be. So let's stick with our code. Right now it's much smoother. Okay. All right. And next step is smoothing our. Before that, let me collapse this to a function. So camera Well, yeah, then we actually need to do this part. So let me delete this. Here, another one, we need rotation rate. Let me define a category. Camera controls. Now rotation rate also can be left with the input axis value. So get IA rotate camera. Just like here, we need to add multiplier and a multiplier with world delta seconds. Okay, and should go to set rotation rate, and that should go here. This can be too fast. Yeah, sorry. We might not need 100 here, or we may even have to slow it down. Yeah, actually, we should clamp this. No need to clamp because this one is not going to increase more than 1. So perhaps 0.3. Yeah. Okay. So we can zoom in, zoom out, move. All right. Now let me collapse this part also to a function rotate camera. And if you want to use an isometric view in the game, all you have to do is change this to a orthographic, and it will work. See, but zoom in zoom out won't work. If you want to have zoom in zoom out, you just like we increase the target arm length, you have to increase this ortho width. By changing ortho width, you can do zoom in and zoom out, but I don't want to add that part here, but I hope you can do it on yourself by yourself. If you can't, just let me know in the comments. I'll show that part as well if it is important for you. What is this error? Oh, this one. Okay, so I added some more space so we can test the system properly. We can now move here, go here, like in a proper top-down game. So yeah, the system is working nicely, and we can rotate, zoom out, zoom in, move in the world. Alright, so I'm gonna stop this episode right here, and thanks for watching. As always, project files will be available for the download in Patreon page. Link would be in the description below, and if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.